And this is really the connection between limits and calculus. Calculus is about rates of change. Derivatives, to put very, very simply, are just talking about what is the slope of a tangent line at a specific point. And first of all, we have to discuss what is a tangent line, and related to a tangent line is a secant line. So anytime you take 2 points on a graph and join them with a line, that's a secant line. And we'll see that secant lines kind of give you an average. In our next example, they're like the average speed that it took. If I went and I drove from Winnipeg to Portage la Prairie, and it's 50 kilometers away, and it took me an hour, that would mean on average, I was driving 50 kilometers an hour, okay? But I shouldn't drive 50 kilometers an hour through a red light. That's or a stop sign. Those are bad things to do, okay? It's not like I'm always driving 50 kilometers an hour no matter what. Sometimes I'm going faster, sometimes I'm going slower. But on average, I went 50 kilometers per hour. So a secant line sort of looks at an average, whereas a tangent line looks at an instantaneous moment. I'm driving to Portage la Prairie, I look at my speedometer, I'm going 100 kilometers per hour. That's how fast I'm going at that instant. And on a graph, a tangent line touches a curve at one point, and we say it usually doesn't cut through the curve. There are some special cases, but generally it just touches the curve once at that point. So it doesn't touch it once and go through. That's not a tangent line. A tangent line is like, ooh, I kind of want to touch it and sort of have the curve bounce off the line. That's sort of what I'm imagining. So your secant line looks at an average rate of change. How much did you change your x values by? How much did you change your y values by? It's change in x over change in y. That goes back to a grade 10 concept that you learned. That's just a slope. So when I have a secant line is a straight line. It has a slope. Even though the curve did different things in between, on average from this point to this point, your slope would give you your average rate of change. An instantaneous rate of change, well, that's your tangent. You're looking at how fast things are changing at a particular moment. So when you're driving, it is looking at your speedometer and saying, how fast am I going right now? That's my instantaneous rate of change. And that's what calculus is all about. So rates of change, you've seen it before. You've seen slope, rise over run, y2 minus y1, x2 minus x1. Sometimes they use the word gradient. Okay? That's often used in roads. The gradient of a road, how much it's increasing and going up or going down. If you're driving through mountains, it's much more important. They don't worry about it too much in Manitoba because there's not that many crazy slopes we have to worry about in Manitoba. Physics likes to use the delta symbol. Delta y over delta x. Change in y over change in x. And calculus calls this rate of change the first derivative. dy over dx. Also an idea of change in y over change in x. Okay, so here's the following graph. You're driving somewhere. Distance from Winnipeg in hundreds of kilometers. I don't know how in 1 hour you got 200 kilometers away from Winnipeg, driving very, very fast. Okay? And then You realized you were going to pick up a friend. So you had to drive back 100 kilometers. Meanwhile, driving back that 100 kilometers, you took your time, maybe because you got a speeding ticket here. I'm not sure. And then you think the cops are gone. You drive really fast again. Oh, here you're stopped for an hour. Maybe the cops weren't gone. And then you just take off. And the Arrowhead, you're driving, and you just never come back to, you just keep on a pathway away from Winnipeg forever. Yeah. So if from 0 to 1, you went from a distance of 0 to a distance of 200 kilometers over a time of 1 hour, I'm just glad I didn't use the word minutes here. Otherwise, this is just crazy, okay? Does it make sense that you're going 200 kilometers per hour on average? And apparently, according to this graph, you had some steeper parts than that even. You started off slow and then just took off. Okay. Now, if you went from 1 to 3 hours, notice that now your distance has gone back 100 kilometers and forward 2 hours. Does it make sense that your average speed is negative 50 kilometers per hour? Now, we don't often talk about negatives when we're driving because your speedometer on your car doesn't go in the opposite direction, okay? But in mathematics and in physics, when we have a direction, in this case we're talking about going towards Winnipeg and going away from Winnipeg, this negative 50 kilometers per hour just means that you're returning in the opposite direction that you came. From 1 to 4. Oh yeah, sorry, I was like, that's not right. From 3 to 4, yes, you've gone up 100 kilometers in 1 hour. Looks like you're following the speed limit, but maybe that was a 20 zone, and that's why you got stopped right here. But does it make sense in part D, from 1 to 4, you were 200 kilometers away from Winnipeg at that moment. Even though you drove back and drove again, you've technically not gone anywhere in that time. Your average speed is 0 kilometers per hour. Okay? This is really disappointing if you go for a run and you calculate this. You're like, okay, I want to get in shape. You leave your house, you run for half an hour, and you get back to where you started. Your average speed is 0 kilometers per hour. I went for a run. What's your average speed? 0 kilometers per hour. That's not very, doesn't feel very good as a result that way. And then from 4 to 5, also 0 kilometers per hour. So these are all average rates of change. And what we're going to be looking at in calculus is more instantaneous rates of change. So all the average rate of change is just picking the beginning point and the end point and figuring out the slope.